Hey, good morning. Thanks for coming to my session. I'm Nick McSpadden. I work at Facebook. I'm a client platform engineer. So we basically sit there and break all the things that you're using. This session is about source control. So the title of the session was using source control for literally everything. And I take that very, very seriously. Everything, and I mean everything you do, should be in source control. Everything. If you've ever had to worry about any script you've ever written, any text file you want to save for later, source control is the reason why we want to do that. And I'm going to talk about all the different things that we're going to do with source control later on. We're going to start off by talking about Git, which is the most common form of source control. So in a lot of ways, this session could just be called Intro to Git. A lot of people here already expressed some confidence that they already have some familiarity with Git. So I'm going to hopefully go a little bit faster through the basic stuff, and we can get more to the meat of it. But source control. Okay, what does source control actually mean? And this comes down to the idea of, think about what it was like 15 years ago to try to have multiple people edit the same Word document. All right, so we're in 2003. Dude and Dudette, they've got this file. So Dude makes this file. He writes this Word document. He then puts it in an email and sends it to Dudette. So now they both have the same copy of the same file. And then Dude does something terrible. He makes a change to this file. History's greatest monster. He edits this file again. And now he and Dudette have different copies. They don't have the same file anymore. Dudette now has an old version of that file. So if they're working off this as a reference document, one person is now out of date. Now what happens if Dudette also changes this file? They now both have two different copies. They no longer have anything in common except their ancestry. So what's going to happen if somebody wants to come back and put these back together? There's going to be pain. Maybe they Rochambeau for it to figure out who has to do it. All right, do you want to sit there and copy and paste line by line all those changes back in your document that you're trying to merge two Word documents? Do you remember trying to do that back in Word 2003, right? That's no. Oh man, I'm breaking out in hives thinking about it. Right? So collaborative editing of things like that was a huge pain in the butt. Nobody liked doing it. There was no good mechanism to make that happen. Nowadays, Word has collaborative editing features. Now we have things like Google Drive, which lets you collaboratively edit docs on the web. But a long time ago, we didn't have tools like that. So if you're thinking, if this is just already hard just to merge two Word documents together, think about a complex software system with thousands of files, thousands of lines of code, all of which people are working on independently, trying to keep that all in one place, merging that all together. That's just terrifying. Programming projects, like Monkey here, can involve lots of files, lots of folders, and lots of people. Every person who works on this software project needs all of this together, right? You got to have all the files to make a meaningful contribution. And so we also need a way to figure out who's making what changes, when, how, where. We need to be able to track all this stuff over time. And so source control is the sort of solution to this. It's the mechanism that we can track independent changes made to parts of this whole over time. And it's mainly used for programming projects, but we'll talk a little bit about later about why you can use this for pretty much anything that isn't a binary. There are three main tenets of source control, right? First off, everybody has to have everything. You can't build a program without all the pieces, right? If you're going to compile a big program, you're going to make a game for your, you're going to make a mobile app or something like that, you're going to make Monkey, you got to have all the pieces together, okay? Having just a small chunk of it isn't enough. So everybody has to have everything. Everybody has to have the ability to make changes and contribute it back. One person, it's very rare that one person is responsible for all the code in a project. It's in large programs like Keynote, it's not one person doing it. It's a whole team of people working on many different aspects of it. So everybody has to have this ability to make these changes and then give it back to everybody else. We have to find a way to distribute it back. And more importantly, you also have to have a way to understand what changes other people made and how to incorporate them back into your own. You have to have a way to absorb those changes other people are making, right? So think about the really early versions of Google Drive, Google Docs rather. Remember how terrible it was when the very first time you tried to actually edit like the same line at the same time as somebody else, and the cursor would keep jumping around before they added the highlighting for who was actually editing what? The very first version, they didn't actually have colored highlighting for different people. Oh, it's a disaster. Right? So that's the kind of thing where you learn over time having a right way to absorb people's changes without colliding is critical for source control. This will be, obviously we'll be posting the slides, so here's just a list of links where you can learn about kind of like getting started and what to do with it. So let's talk about Git. What is Git? Well, if you ask the dictionary, you get a very specific answer. A very unpleasant, contemptible person. Which is not entirely wrong for most of the times I use Git. The good news, though, is that Git is really popular. It's the most popular version control system there is right now. And if you Google Git, what is Git right now, you get lots of good resources, right? There are books written on this that are for free. Atlassian has a good tutorial. The basic source control Git basics book is a free web book that you can just get all the information you could ever want about Git. There's a lot of stuff about Git. There's kind of one basic problem, though. In my opinion, most of the material on getting started with Git is really, really dense. It's really, really hard to absorb. I find that most of the Git tutorials kind of jump a little bit too far into technical detail without really kind of giving you context. So hopefully what I'm here to do is provide you more of the context and less of the gunk. So this is just from Visual Studio. Their website has a really good example of what is Git, which is basically that it's the standard for version control. It's a distributed version control system, meaning everybody who has a copy of a Git repo has the master. Everybody has an independent copy of the whole project, and any single person could become the centerpiece of it. And the idea is that we distribute everything out to everybody, so that way there is no one dependent server. There is no one dependent source. Everybody is the source of truth. This is going to become an important concept later when we talk about time travel. Git is not the only source control tool. There are many source control tools out there, like Mercurial and Perforce and SVN and things like that. But today we're talking about Git. Git is not the only one, like I said. It is the most popular one, mostly because of places like GitHub, which is a website for managing Git repos in the cloud. That has become a very popular place for pretty much all MacAdmin open source projects to go. So Git has some basic core ideas, one of which we already talked about. Everybody has everything. Everybody who checks out this Git repo has everything they need. Git has one master. There is one master branch for the project. This is the source of truth. Whatever is in master is your project. You can do all kinds of crazy stuff in branches, which we'll talk about, but the master is it. Whenever Greg Nagel releases a new copy of Monkey, he builds it from master. Whenever auto package gets released, it's built from master. Master is your truth. When you make changes to Git, when you do anything in a repo, you only ever add data. It's almost impossible at any time to actually remove things from Git. Everything involves making a change and recording that a change was made. Even if you delete a file, if that file was in the repo at some point, that's in history. Git keeps all history forever. Okay? This is where time travel is going to become meaningful. Every revision in Git is a snapshot of the whole project. So let's look at a metaphor. Time machine, right? Time machine's a great example of the snapshot idea. If a file hasn't changed between time machine backups, it just records a link that says, okay, look back at the file from the previous backup. And you can go back in time, far back into your time machine snapshots to see what a file was at any given time. This is very similar to what Git does. It has snapshots for every change that was ever made, and you can go back to any point in time to find it. Wikipedia is a good example of history. Every time somebody makes an edit on Wikipedia, that goes in the edit log. Even if that change is then later reverted, if somebody goes back and says, no, your edit here was terrible, you're a terrible person, you should be banned from Wikipedia, it's still recorded. And you can go back in time and look at what Wikipedia pages look like anytime in their edit process. So Git kind of combines both of these concepts. We retract all of history, we keep all the snapshots, we want everybody to do all this together at the same time. That's the theory. Okay, some common Git terms you need to know. Repo, right? Short for repository. This is just the project. Monkey is a repo. Auto package is a repo. If you have a repo on GitHub, you can put whatever you want in there, but each individual repo is a project. When we talk about commits, that is when essentially you hit Command-S on your changes and push it back into the project. A commit is when you've made a change and stored it in history. It's a time machine snapshot. That's a commit. Master, as I said, is the source of truth. Everything else we do in Git is always relative to master. Branch is a deviation from master. You sort of make an alternate timeline. You can work on stuff without affecting master, and then later on we can bring it back in. We'll talk about that. Git starts at the terminal. If you've never used a terminal before, this is going to be hilarious for you. So installing in a Mac OS X is actually really easy. You type in pretty much any of the Git commands, and you'll get a prompt a lot like this. You type in Git, you type in Xcode. If you don't have Xcode installed, you'll get a prompt that'll ask you to download it. So any machine, easy to do. Easiest way to find out if you have Git or not is git -- version. Just tells you what version you have installed. By default, if you have Xcode installed, you'll get this version, 2.11.0. What are the things you'll need to do in most cases, especially if you use GitHub? Is you need to tell everybody else who you are. This information, your name and email, is going to be recorded in every Git commit you make. Every Git commit has to have an author and an email. Now, if we're ever going to be working on coding projects, you got to have a good editor, right? You got to have a good thing to work with. TextEdit is not an editor. TextEdit is a travesty. So use something like Atom, TextMate, Sublime. Use your favorite one, Vim, Nano, whatever you're familiar with. Use something good. Don't make me sad. So we're going to make a Git project. Can you read that back there? OK, thanks. Crisis. All right, so first off, we're going to make a folder, my first Git. We're going to put it in the code folder. We're going to go into that code folder, and we're going to type git init. That does one simple thing. Declares this folder is now a Git repo. That's all it is. It makes this now a Git repo that you can track things in Git. What's going on? Git status tells you where you are and what's happening at any given time. By default, I'm on branch master. This is the initial commit. Nothing's happened in the project yet. The state of this repo is clean. Everything's fine. So let's go ahead and add something. Let's make a random file. Just make a file called hello.py. Just touch a file, git status, and what does it tell you right here? You have an untracked file. Something is now in this folder I haven't seen before. Git has a very simple interaction with everything. Here's the state. What do you want to do? This is the core behind nearly all of Git's development, is telling you, here's where I am now. You tell me what to do with it. Git is very good about giving you information about what you can do with your options. And in this case, it's telling you, hey, you can use git add to try and add this file. Is that what you want to do? So untracked files are things that Git does not know about. You've put a file in this folder that you haven't told me what to work with. What do I do with it? This is an untracked file. Because it's in red, this repo is currently dirty, meaning there are changes sitting here that I haven't been told how to handle yet. You can't do anything else until you figure out what to do with this stuff. Anytime you make changes to a file and you hit Command S, you've made the repo dirty, and you have to decide how to deal with it before you can continue. So we're going to make a new commit with this file, which means we first need to add it to the staging area. We have an untracked file we're adding to staging. So git add will take a file and add it into your staging area. So when you hit git add and then git status, what do you get? It says, hey, here's this change you've made. Do you want to commit this? This is what I'm ready to do if you ever hit git commit. In the staging area, it's just saying, these are things that are going to go into the commit if you make one. That's all it's telling you. This is ready to go. If this is not what you want, you should figure it out now. But this is ready to go into the commit. Now we go ahead and make the change. Git commit -m. Whenever you do a git commit, you have to have at a minimum 3 things: the author's name, the author's email, and the summary. The summary is just like a 1-sentence, what does this commit do? That's all it is. What's the point of this? And so you can pass that in with -m really easily. Just say, this is my first commit. When you do that, it makes your commit for you. And then if you look at status again, you're good. You're clean. You've got a commit made. You're clean. But that doesn't tell you how many commits you've made so far. So how do we actually see the history? That's what git log is for. So I'm adding the no pager argument to this because by default, whenever you open a git log, it opens it up in a default editor such as Vim. If you're not familiar with Vim, getting out of Vim is a hilarious exercise for computer science students. There's a running joke that if you ever want to get a random string, open up Vim and ask a first-year CS student to try and get out of it. What git log shows you is what the history of the project looks like. So here, we're seeing I've made my first commit. I made that on July 7th, because I clearly prepared for this very well in advance. Cool. We have our first commit. Everything goes downhill from here. It's only going to get harder. So let's add some real content. We have an empty file. The empty file obviously has no meaning, doesn't do anything. So let's actually put something in there. Let's just go ahead and put some code in there. Go ahead and open up this file in your editor and type in user bin python print hello world, just like that. It's just a simple program that just prints out hello world when you run it. That's all it is. We're going to add this into the hello.py. Now, again, Git tries very hard every time to tell you what your options are. We made a change to a tracked file, and so it's saying, hey, what do you want to do? You have to stage this, add it and commit it, or get rid of it. So again, we're going to git add it to put it into the staging area. We're going to commit it. The other option, of course, is that git checkout can be used to get rid of it, meaning go back to the state this file was in last time I cared about it. So we have unstaged changes waiting. The repo is dirty. We have to do something about it before it can go forward. So again, let's add it. Add it, commit it, we're good to go. You can do all that in one step, git commit -am, meaning take everything in the staging area, take everything ready to go, put that into the commit along with this message. You make that commit, look at the log, you're good to go. I got 2 commits in there now. Fantastic. Everyone celebrate, take a drink. So git log always shows you reverse chronological order, right? Newest commits are always on top. Git commits are referred to by their hashes. The commit hash is the first 7 characters of that long hash string right there. I am terrible at microphones, apparently. So that first commit I made, right, that is 3762 AAB. That's how Git is going to refer to this commit from now on. The second commit, obviously, is going to have that 7-character string. In most cases, you don't need to worry about that too much. If you ever need to go back in time to look at specific commits, this would be the way that you could refer to it. So where are we right now? Okay, the head is a concept in Git that just tells us where it thinks you are in the timeline. So if we're looking at a timeline kind of like this, if this is our master branch, head is like the tip of this branch, right? So head is always, where am I right now? What is head pointing to? It's at this spot in history. Right now, head is on master, meaning we are at the tip of the master branch. There's nothing in the future. There's only stuff behind us. We are on the bleeding edge right now. So now we have code in our repo. We have one little file in there. Very simple. Nothing wrong with our Git repo. If it looks great, people would be smiling and happy about it. We're going to branch out a bit. Branching is one of Git's best features. A branch is a completely separate copy of the same repo where you can make changes to things independent of master. It's an alternate timeline. I'm sure everybody here has seen Star Trek or read science fiction or watched any kind of sci-fi movie with time travel, right? Alternate timelines are usually always terrible. They always end in tears and sadness. That's true for Git as well. But if you do it correctly, you can, go back and you can go and change time without necessarily ending up being your own grandfather. Remember the important thing. Master is always there and is always your source of truth. So you can make branches for anything you want. Git branch tells you what's available. Git checkout -b means make a new branch and switch to it. So we're going to make a new branch right now where we're going to add more code to hello. So I just called it add code to hello. The name is just for your own convenience. It's all it is. You can name it whatever you want. It's just for your own reference. No one else cares. We're going to make another change to hello.py. Let's open it up. Let's add some Californian in there. Sup. So again, you have unstaged changes. You got to add it, make a commit into that branch. Commit am, hello, py. Cool. Now we're back in a clean state. We're on this branch. We have a commit in there. You want to see how branches work? Look at that file. Switch back to master, look at that file again. In most cases, if you have an editor open, it'll automatically update the edit, while it's open in your editor. So if you have it open in Atom and you switch branches, you'll see the file actually change right in front of you. But you can see right here, you switch back and forth. One of them has our changes, one of them does not. That's how it works. Whenever you switch branches, you switch back to the right timeline, Git automatically updates all the files that were relevant to show you what they look like according to what that branch knows. So Git, again, looks at snapshots. Every single commit, every single part of the branch is part of history. Cool. Let's go a step further. Let's make a new branch. We're back on master. We're going to make a new checkout. We're going to call this one British. Pip, pip, cheerio. I'm terrible at British. I apologize for anybody who's British in the room. So we're going to do another change to this file in a different branch, totally unrelated to the California one. Got to commit it, make it slightly more royal, class up the place a little bit. Okay? So we've made this commit. We have it here. It's ready to go. Where are we right now? We have a master branch. We made a second branch and made changes here. Then we went back in time, made a new branch and made changes here. We now have two different copies of the same file in two different branches. This is a recipe for disaster, which makes for a great demo. So we're going to merge these back into master. Because we're masochists, we're going to merge both branches back. So what's going to happen is I'm going to present this visual metaphor for Git merges. So you've got changes on one side, and you've got master on the other, and you got to have them run forward and meet each other. So we're going to do that right now with the California branch. Switch back to master, and then use git merge to shove those things together. It's actually really easy. Git merge, and it tells you right there. What did I do? I changed one file, I inserted a line, and I deleted something. Now, if you look at the git log, you'll see we incorporate it back into master. It's now in git history. So at this point, we made our change here. We came back to master. We are now right here where master has happened. But now we have a problem. This is the correct timeline. This is now working off the wrong timeline. This is going to go back and reboot the series. Okay? And it's going to be terrible this time. It's not a good Star Trek reboot this time. We want to clean up after ourselves. So if you look at git branch, you'll see that by default, it leaves all the branches behind. So clean up after you've merged your branch. It worked the first time. What happens now if we try to merge the other branch, if we try to merge the alternate timeline? Well, I'm a little worried. I'm a little scared. Kind of panicking. It's going to be fine. Merge conflict! Didn't work. Why didn't it work? Because both branches changed the same file and had a timeline clash. This is bad. This is what git merge looks like pretty much every time I ever do it. Yeah, this is what's happening in your code. You're shoving together a whole bunch of code, and everything just went horribly wrong. That's a merge conflict in visual format. So one of the most important concepts behind Git is dealing with merge conflicts and conflict resolution. So if you look at hello py right now, while you're in this merge conflict state, you'll actually see it gave you a bunch of stuff in here. These are called conflict markers. This one up here, and then this one right here. Essentially, it's telling you, this is what's coming in, this is what I have now. Which one of these do I work with, right? Git cannot make decisions. Git is not a very smart system. It's not an AI. It is a tool. And the one thing they designed Git to do in all cases is present you with options. What it's telling you right here is that you've given me conflicting instructions. I can't resolve this on my own. You have to decide, how do I resolve this merge conflict? Which one do I want you to use? Head tells you right here, this is what's currently on this line. As far as master is concerned, this is life. You told me to merge in this branch. This is what you're trying to merge from into. Merging this into this. So now you have to decide, as the author, what to do about this. Git will not decide for you, ever. Git will stay in this interrupted, halted timeline state until you figure it out. So what do you want to do? Be California, be British? Well, The good news is resolving conflicts is actually pretty easy. All you have to do is delete the parts you don't want. In this example, this is an easy change to do, right? All we got to do is we could delete that part right there, delete that line, delete the markers. We'd be good to go. Git resolution is easy. It's never easy. It's only going to be terrible. It's terrible. Don't ever do this. Oh, this gives me hives. No, seriously. Merging things generally isn't that dangerous when you're not having conflicting changes. But with any project you'll ever do, there's inevitably going to be a time when you and someone else are going to work on the same file. More importantly, you and someone else might touch the same line. That's when you get branching timelines, right? When two different people independently work on the same file and you try to bring them back together, that's a situation you have to resolve. And in large software projects, really complicated ones with thousands of contributors, that can be a really meaningful issue. So in this case, this is an easy fix. I'm just going to delete the British stuff. You just got to delete that line right there, line 3 where the conflict marker is, and then lines 5 through 7 are the conflict markers for the British side, as well as the change that I made. Resolve it back, save it, cool. Once you've saved your changes, Git status again tells you, okay, you're now in a state where you have to fix your conflicts. So again, Git tries to be very helpful and tell you what your options are to move forward. Here's how you progress from here. So the suggestion right here tells you what to do. Fix your conflicts, and then run git commit. Well, we fixed our conflicts in the last slide, right? We're down at this state now. So now I'm just going to go ahead and run git commit again. Cool. And what you see there is that it merged. It makes a merge commit showing I took the changes you made and I incorporated them back into master. In most cases, when it asks you what to do when you make a git commit at this point, you can just kind of roll with it. Merge commits are something we should generally not touch as humans. Let Git do what it wants to do in those cases. Cool, it worked. If you look at the log, there's our merge, right? We see the merge branch happen and made a git commit for it. And now we have a clean working tree. We don't have any, we're not dirty, everything's fine. And the only downside is that we didn't actually do anything, right? We merged that branch in and essentially deleted all the changes out of it. So Git, as far as we can tell, is very happy. It got what it wanted. It got clean, it got merged, everything was a success. In reality, one developer, the guy who wrote branch B over there, is like, wait, what happened to all my code? I just made all those changes. Where did they go? So this is an issue that obviously becomes much larger and much more magnified in big projects. In this little contrived example, it's really easy to resolve because you're the only author. But it's something to be aware of when you work on projects like on things like GitHub. GitHub is great. GitHub is a cloud-based Git service. It allows you to break the internet even faster than before. If you thought Git was hard to start with, wait until you work on big projects where you can break everybody. This is going to be great. All right, so most of the popular open source products, like I mentioned, are on GitHub already. Monkey, AutoDMG, Imager. Almost everybody in the MacAdmin community generally ends up putting something on GitHub, right? Anytime you make a script, a project, even something that you want to put on Jamf Nation, put it in GitHub, right? There's no downside. There's no reason not to. It's a great way to publicly share information. Even if it's just a list of things you got to pick up at the grocery store, put it on GitHub. Why not? Right? So one of the nice things I like about GitHub, though, is that it has actually really good UI for most of the common Git operations. Now, obviously, in this example, what we did is we spent a lot of time using the command line, adding things to Git, running the command line tools, which are valuable and helpful, and I think everybody should understand them and understand the core of what they do. But in all honesty, most of the time, what we'll be doing is working with an interaction of the command line and the GUI tools that are provided. So you can make a new repository on GitHub really easily. If you haven't already signed up, you should do that. You can make a new repository. GitHub gives you free unlimited public repositories, meaning things that are open to anybody who wants to look at them. You got to pay for the private ones. There's also, I'm talking about GitHub, but there's also many other examples out there, GitLab, Bitbucket. I'm out of examples. Well, anyway, there's many others, I'm sure, that allow you to host Git repositories. I think Bitbucket lets you have private ones for free, I think, right? Yeah, so if you want to have private code that's your organization only or things like that, Bitbucket would be a good place to look if you don't want to pay money. But either way, back to the GitHub example, we're going to make a new README. We're going to make a new repository right here. I'm going to go ahead and call it PSU Mac Demo. And as soon as you do that, it tells you right here, okay, look, you can create a new repository in the command line. If you recognize right here, git init, right? That's what we did the first time. Make your Git repo, add some stuff to it. Here's your Git commit. Then you have to do this fancy thing here that says git remote add origin. The concept of remote and remote master, remote origin are really important in distributed Git. What we did, as an example earlier, was just local on my machine, I'm playing around with Git. You can do whatever you want, your own repo, no one's ever going to care. Once you start working in a distributed Git environment like GitHub, it starts to matter a lot when you have to worry about what master and what remote has. I'm going to have another contrived example here. This right here is me. I can do whatever I want to my repo. No one will ever care. This is everyone else. One of the reasons why we have things like dictionaries, thesauries, things like that, is that we can all establish common vocabulary. The birth of language, the growth of language, is that we all have a common framework for communicating. We all talk about the same things. When I say this is a weird blue microphone box, people know what I'm talking about. This is a terrible example. Wow. When I say that this is a table, people know what I'm talking about. People know what tables are. No matter what language you speak, the concept of a table is pretty common in the human environment. This allows communication to work just well. When we talk about Git, the same rules apply. I need to make sure that my copy of Git, my Git repo, has the same frame of reference as your Git repo, as everybody else does. If everyone's working on a project, we have to make sure we're talking about the same things. So Git, when I say distributed version control service, I mean everyone has a copy of the same thing. Everyone should be able to understand the same concepts. Remote master, remote origin. In that case, if this is GitHub right here, the everyone else portion, this is remote. This is someone else's Git server. That is not my machine. Someone else has their own copy of the Git repo on a cloud, that's GitHub, and it has its own copy of master. As far as the rest of the internet is concerned, GitHub's master is the master. If you look at, the GitHub master for Monkey, that is the master everybody else refers to when they look at what Monkey does. Remote master. Remote meaning not on my machine. So I branched out into this topic because I'm doing it again. I want to make it very clear that when you work locally with your own stuff, you can do whatever you want. When you start working with public Git repos, like on GitHub, good behavior becomes really important. So let's say we have our Git repo, right? We want to go ahead and add this to our GitHub repo that we just created. So again, git remote, add origin, and then the URL that it provides me. Origin meaning, again, GitHub, the source of truth. I'm then going to push it. Ignore the credential stuff. That's just my machine. You put in your username, your password, cool. You need to authenticate GitHub at least once. You push it, and it says, hey, look, done. I'm going to compress all your stuff. I'm going to upload it. Cool. Now we have GitHub has a copy of my master branch. My master matches origin remote master. And there it is. My nice little branch. You can look at this in my GitHub repo right now if you wanted to. Right? This is live. This is on the internet. And if you look, it has the commits that we made, the ones that we played around with, the merge commits, the test commits, etc. They're all there. So when you're working in GitHub, as opposed to just locally on your own machine, you don't obviously necessarily always have control and the ability to just merge things back in the master whatever you want, right? Usually you have to make a pull request, meaning you've made a feature change and you've said, Greg, I fixed Monkey for you. It was terrible before. Merge my pull request. Then he comes along and says, no, your code is terrible. This happens to me so many times, it's awful. All right, so you file a pull request to say, hey, please merge my stuff into your master. This is where time travel becomes an issue. If you do things that go back in time and rewrite history, and you try to merge that back into public GitHub, you break the repo for every other person. And I'll talk about that in detail. Some wise person on the internet once told me that to err is human, but to really, really screw up, you need Git. Boy, let me tell you. First off, when you're working in Git, don't work on master. Just don't do it. If you see the master branch, run away screaming the other direction, all right? Use feature branches. They're powerful, they're helpful. Don't mess up your master, because if you mess up your master and your master is now different from everyone else's master, you're not talking the same language anymore. You're saying table, other people say chair, right? You have to make sure you have the same frame of reference. Don't mess up your masters. Make sure that your master keeps in line with the remote master at all times. It is never, ever appropriate to rewrite history. When I say rewrite history, I'm going to stop for a moment and go back to this drawing. What we did in our contrived example that created a merge conflict, we started at the same place. We had two branches that did different things to the same file. We tried to merge them and had a conflict. That's how we ended up having to fix it. Now, what if instead I did something even worse? What if I said, screw your merge conflict. I don't care what everybody else has to say. I'm forcing my stuff in anyway. I'm going to go back in time, ignore your change, and put my stuff in before you change it. I'm going to check back out to this change, make it here, and then I'm going to force that back into master. And then I'm going to make a pull request to master in remote that says, hey, I changed time up here, but you didn't. What ends up happening at that point, you have time travel. Everyone else, they diverge. They're different, right? You reboot the Star Trek series again for the third time, and this time it's even worse, right? So time travel in Git is really easy to do. You go back in time, you make changes to history before other changes are merged in, and then you say, please take it. This ruins it for everybody else, right? You can't mess up the timeline, because if you break public master for everybody else in the project, whenever somebody else tries to make a commit back to master, tries to make a merge back to master, they have a different master than you do. You have a huge collision. All the commits now are divergent from each other. It just creates a giant mess. This becomes spaghetti super fast. And if you've ever wanted to see horror in your life, look at the Git log of a project that had a giant spaghetti mess like that. Git hell is real. It is absolutely real. There are no 10 circles. There's only the 10th circle, and it's terrible. All right, so the good news with Git is that you can always get back to where you started. Always. Git gives you a lot of ways to get stuck in hell. This is a true statement. But it also gives you a lot of ways to get out of hell, right? So you end up stuck in a horrible place where your merges are bad. You can always check out and go back in history and then fix it without breaking public master and kind of get back to it. Worst case scenario, what I tell most people to do if something goes horribly wrong, just delete it. Check it out again. Seriously, delete your local copy, check out master again, start over, copy and paste your changes in. It's honestly usually the fastest way to fix most of the problems you encounter when you get stuck in rebase hell. Important rule, and GitHub has this all over their help section, and I can't stress this enough. If you're putting things like passwords hard-coded in your scripts, private keys, certificates, and you're putting that into public GitHub, question all of your life choices, because they were all terrible. All of them, okay? Question every one of the things that you did to get to that point. Don't ever, ever put secrets in GitHub. Ever. Just don't do it, okay? Because there are bots that sit there scraping GitHub 24/7, nonstop, looking for passwords, secrets, and details like that. And they will find them. You can have a password published for all of 10 seconds before you realize, oh, shit. And then you take it down, you delete your repo. But you know what? Doesn't matter. That 10 seconds, there are 1,000 bots that got it already. And you better believe they're going to use it. They will try to figure out, who do you work for? Where are you? What can I get access to with this? They will do it. Don't ever, ever put sensitive data in your repo, right? This kind of comes down to a core rule of most programming in general, which is separate out your config from your data. Don't put secrets into your code. Instead, consider writing code that looks up a secret from a trusted source on demand. Don't hard code your password. Instead, say, hey, where can I read the password from stored somewhere else, not in my code? Read that rule again. Do it one more time. Seriously, okay? This is one of the most important rules for GitHub and any public repo in general. Secrets are bad for code. Don't put them in there. You'll never get them back. All right, so we have time for questions. We have 30 minutes left. I'm going to spend some time doing a little bit of an actual interactive demo with Git. I'm going to show you some stuff on GitHub. But in the meantime, does anybody have any questions first before I move on? This is going to be fun. This was a terrible decision. Yes, question.
Can you have a private branch of a public project?
No. So let me quantify that. When you check out your own Git clone of a project onto your machine, that's your machine. Nobody else has what's on your machine. As soon as you publish that back to GitHub or whatever you use, either on your own fork or the central repo, that's public. Okay? There are no private branches. There are only private copies of the project. So short answer is no. You cannot have a private branch of a public repo. You can have your own copy, which you work on and don't share with anybody else. But if you want to publish that back, it's public. The only way to have that private is by having a private repo, which on GitHub is a paid product. Any other questions before I move on? No worries. What's up?
So when you check out, I'm pretty new to Git, so if you check out or clone a repo down and you start doing some changes, let's say you go to bed, next day you wake up, you want to keep working, do you do another pull in case somebody else did change something?
Awesome question. Thank you for asking that. The answer is yes. One of the things you have to do with any kind of project for which you are not the only author is you have to make sure whenever you're making changes, you're always making changes on the latest timeline, right? Because otherwise, again, you end up in a really sad place. You don't ever want to have a situation where you're making changes in the wrong timeline, right? You don't want to go back in time and say, oh, I'm going to check out and mess with this file that maybe somebody else already did last night while I was sleeping. You always want to be at the tip, right? You always want to pull to make sure you're at the tip of the master branch. And we can talk about rebasing, which is the horrible, dirty word in Git. It's amazing, but it's also awful, right? Which kind of explains how this is going to happen. Question? Thank you.
Thanks. I think this is just clarification on what his question was, but so are you saying to always pull before you are going to commit your changes, or just basically always pull and be like OCD pulling
I'm going to say
all
both.
the time? Okay.
So there's never a bad time to pull, generally speaking. Okay, let me quantify all this. This is a introduction to Git talk, right? So a lot of what I'm saying is general and generalized and generally true. There will be many cases for which I will be completely wrong. So there are going to be cases and there are going to be situations where always doing a Git pull before you do anything is a bad idea. You will generally know those situations before you encounter them. If you know that someone else on your team is working on the same file, maybe you're both trying to solve a problem in a different way, then that might be a time when you would want to communicate with somebody else who's working on that same project. But barring those edge cases, most of the time, you will want to do a pull before you start working. Okay? Make your branch after you've done a pull, so you're always on the latest timeline. Before you try to put your stuff back into master, pull to make sure you have the latest copy of master to merge back into. Rebase your changes, and I'll show an actual example of that. Rebase your changes back onto the latest timeline, back on a master, and then go ahead and submit. But generally speaking, any situation that lets you end up time traveling is a bad idea, right? It's super, super important to never, ever misbehave in a public repo. Any other questions? Over here?
Can you discuss a bit what forking is and when you would use it?
Absolutely. Cool. Where's my mouse? Okay, this is the repo that I created, right? This is the demo repo that I made. Right now, this is just me. Nothing else happens here, right? We can look at, for example, this is really awkward side launch. Okay. We look at Monkey, right? Monkey has 55 different people who've contributed to it, thousands of commits. It's a big project, right? There's a lot of stuff in there. When you want to work on a public project, here's a general strategy that you'd want to do. You fork the repo, meaning you take someone else's repo, you copy it into your own GitHub account with your own fork of it, meaning this is now my version of the same project. You make changes in your project, in a different branch, and you're going to submit a pull request saying, hey, I made changes on my version of this project. Can you please merge them? That's essentially what the process is. All right, so, oh, I actually already have forked this many times. Let's see if I can fork something that I haven't already done. Okay, I don't think I've ever forked Monkey Web Admin. So in GitHub, you have this, let me make this bigger. That's too big. Is that better?
Yeah.
Okay, all right. So GitHub has this nice little fork button up here, right? And if you hover over it, it says, you're gonna fork your own copy of this repo to your account. Okay, and I'm the owner of, I'm part of several different things, so I'm gonna go ahead and fork it to my account. Okay, it's gonna copy the entire repo, not just that, all of the history, all of the commits, everything that ever happened in this repo. I have a complete 100% accurate copy of this. Git is distributed. Every single person who has this repo has the same thing. Okay, that's the important rule, right? So now, this is my Monkey Web Admin 2. This is forked from the original, but this is still my copy. I can do whatever I want to this. And if I make changes and I put them up in my version here, nobody else who uses this product will care. They'll never notice those changes, right? This is, again, my complete separate copy thing. This is my own time machine snapshot. No one else is ever going to restore from my time machine backup, unless they choose to, right? So I've now forked. How many of you have ever used the GitHub desktop app? Cool. If you haven't, I really like it. I think it makes some of these processes a lot easier to use. Really? I should have set this up beforehand. All right, screw it. We're not going to do that.
I forked yours, your demo.
Woohoo! Awesome. Cool. So you forked my repo. Great. If I refresh this now, there we go. We got one guy in there. Yeah, you're my favorite person now. This is actually I actually really like this diagram. This is actually a really great example of how time travel works. This is my master, okay? This is the master branch that I've created. Look here. This is exactly an example of what happened earlier in this session. My initial commit, I added code to hello.py. The first time, I made it Californian. That was the first commit that we merged. At the same time, when I made this branch up here from the same starting point, okay, branch A, this red one, that's this commit right here, number 8. That's that thing right there. When we tried to merge in the British version, right, that's where you see this divergence. We had two different paths from the same point, time travel, that we then had to shoehorn back in. So if you look at that little arrow, this little arrow right here is GitHub's judgy way of telling me, dude, you screwed up. The hell were you thinking, right? So you can sit here and get judged by GitHub every time you do something stupid like that, all right? Now, you look at the one person who's forked it, and this is his version. He just has right here, you can't really see it over the word master kind of blocks it, but there's a little green arrow that goes right along here. And this is his copy of master. Now, as he makes changes and as he does crazy stuff, his line's going to get all jaggedy and things like that. Hopefully not. Hopefully his line will go in a straight path. And eventually, he might submit a pull request. And what will end up happening, my line will keep going, and then his is going to end up merging right back into it, right? So you look at this on something like Monkey. Oh, but it's going to be crazy. Look at that. Look at that gold. Looks like Sam Keeley tried to break it at one point and then failed. Never got merged back in. Let's look at Monkey as a good example of this, because I'm sure Monkey has all kinds of hilarity. I love graphs. Graphs are amazing. See, this is not so bad. If you've been following Monkey, you'll know that Monkey has been under development for Monkey version 3 for a while, which has now hit release. Okay, so there was mainline Monkey, which was master. That was the master branch. At some point in the past, if we go back in time, I don't know if we can go back in time very easily with this graph. At some point in the past, this branch, Monkey 3 development, diverged from the master timeline, right? He made a new branch and he started working on Monkey 3 features. That way he could work on Monkey 3 development without actually ever having to affect the existing product. Really? Oh, fantastic. Oh, look at that. That is pure gold. Oh. I feel all tingly. All right. Right there, right? This is a divergence. One of his development branches got merged back in, and a new one was spawned off of that. And every one of these here, every one of these little lines from master is when he updated his development branch to stay in sync with master. He incorporated whatever was currently in master into his development that he was working on. So the timelines, yeah, they diverge at those 2 points, but he also keeps bringing them back, right? The two movies keep coming back to the same point in time, which is great. And of course, there's this fellow over here who has his own copy, who has been holding it steady for a long time. But as you can see, the Monkey 3 development, every one of these is a commit where he's made some changes, synced it back together, made changes, synced it back together. These are all rebases. Made a change off of that, put it back in, and then at some point, I don't know exactly when, this got put back into the master. This got put into the master branch somewhere. I don't know exactly where. But the point is, you can see how your commits kind of reflect on this graph, right? This is a good visual indication of like what a project kind of looks like. And this is important to keep in mind. Rebasing is one of Git's, again, more powerful and functional features. And when I say rebase, what I literally mean is you're taking your copy of the code, you're looking at master, and you're incorporating all the things that master has done since you started working into your branch. You are moving your home base to sit on top of the master timeline. You are rebasing your changes. I don't know if that metaphor is actually at all accurate for what they actually intended the word rebase to mean, but I'm going to go with it. It's my talk. They can't tell me what to do. All right, so you who forked it, have you made any changes?
Yes.
Cool. Have you committed them?
Yes.
Cool. Let me look at your fork. Cool. Here's his fork. And GitHub tells you right here, look, he's made one change. He is now one commit ahead of master. From his point of view, he is now one commit ahead in time of remote master. Remote origin is me. He has his own timeline. He's making changes on. He's now one commit ahead of me. So if he wants to incorporate that change back into my project, what would you do next? Submit a pull request. Make it happen. When you submit a pull request, what you're literally saying is, here's a change I made. Please make this happen back in your branch. Okay, so right now, I have no pull requests. No one likes my project. I'm kind of sad. One person at least started it. Thank you. You're my friend. I appreciate your support. I'm no longer the loneliest programmer. Someone's watching my project. I think it's me. Yeah, it's me. No one likes my code. Just kind of accurate for most of the things that I do at Facebook. Let me know when you submit a pull request.
Working on it. Now, do I do that from mine or from yours?
Yours. You're submitting a PR from your copy of your fork of the code to mine. You're saying, I think my changes are better than your changes. I think your code is is terrible. You should feel terrible, and I'm going to fix all the things you did wrong. Every pull request says exactly that. Mine keep getting rejected. I don't know why. What a mystery.
Do you see that option just from, oh, actually, catch maybe. Do you see that option to submit the pull request to the original owner from your forked side on, like, do you see it just by going to pull requests and it's an option?
So, yes. I'm trying to think of the best way to show that. So, here is his list of branches. He has a master. He updated it 8 minutes ago. Without actually me making a pull request, which I might be able to do. You know what? I'm going to make this easier on myself. Apparently I'm gonna make this harder on myself. Do-do-do-do. Wow. Give me a second. I never log into GitHub. It's just logged in all the time. All right, we're going to log into GitHub desktop. I cannot side type and watch at the same time. This is awful. Cool. Two-factor authentication, because if you ever do anything of significance, it makes a big difference. I recommend everybody turn it on all the time.
Protect you from you.
Come on, GitHub Authy. I know you can do this. I thought we were friends. Let's try this again. Yeah! Woo! It's the best thing I've done all day. Okay, yes. You got to do your git config. This is what we did earlier with the git config global command. What I like about the GitHub desktop is that it makes a lot of the things that are normally kind of complicated really, really easy to do. Cool. This is the general. Yeah, okay, yeah, fine. Why? No. Go away. Okay. GitHub desktop, right? It's a nice, simple UI for interacting with your GitHub repositories. And you can go ahead and take any of your existing repos and just go ahead and clone them. So for example, I'm going to annoy the crap out of Greg Nagel today by submitting a pull request in this demo. It'll be great. He's going to come yell at me. All right. I'm cloning my fork of MWA2. Okay? Remember, this is my copy. And anything I do in my copy has nothing to do with what anyone else does with Monkey Web Admin, right? It is my own copy that no one else cares about. So again, you can do whatever you want in your copy of any project in Git. It's when you start putting things back into the public that you have to start worrying about being a good citizen. So you can go ahead and, if you have your own private city, you can drive on the wrong side of the road, you can park in intersections, you can, walk in the bike lane, be a rebel. But when you start working in other people's cities, you got to follow the law. Otherwise, the police come and they beat you for being a bad citizen and doing bad time travel. You don't want the time travel police come beat you. Cool. All right. Again, we look at our history, right? These are all the changes that Greg has made to Monkey Web Admin. Thank you, Greg, for working so hard on this project. And again, you have a kind of a vague copy of the timeline here, right? Just looking at the history of commits. Now, you can also see there are no branches on this version. If I want to start working on a part of this project, the first thing I want to do is I want to make a branch. Hello, Greg. Please don't get mad. It's not going to work. He's going to get mad. Cool. I have my branch now. I haven't done anything with this branch, but as you see right here, I have this button that says publish, meaning right now, if you look on GitHub, my copy of MWA2, there is only the master branch, right? That is the only branch that I have here. If I go ahead and publish this, refresh, now I have two branches. Cool. Most importantly, this branch right now has no divergence, right? This branch is even with master on his own, with the organization's origin master. So we're good here. Now, I'm going to go ahead and make a change. I am going to annoy the crap out of Greg. Let's just say I'm going to change the README. Let's open that with Sublime. Cool. I made a change to the README. I made the documentation way better. Much clearer now. Right? Oh yeah. Look at that. Look at that change right there. That's some good code right there. Oh yeah. Oh, I'm loving it. I'm gonna get yelled at so hard. Cool. So again, every commit you make has to have a summary, right? You gotta have some explanation of what you're doing. Okay, committed. Cool. Next step, sync this, meaning make sure that my local on my machine copy now gets published to GitHub. Sync it.
So can you ban contributors from GitHub?
You can always reject pull requests. If you know the person, you can come over personally and yell at them, which I expect to happen in a couple hours. Now again, GitHub does this really nice visual indication, right? Master, and then there's me. Here's my divergence right here. That branch diverted off of master, and I made one change to it. And I synced that back up to GitHub. So now, if I go back to the GitHub page, it refreshes for you, but it says, hey, look, you recently pushed this branch. So now I say, look, you've got stuff you can do in here. This branch now has one commit more than master. I am one commit ahead in the timeline. I am now farther in time than than the original project master is. Generally speaking, when you submit pull requests, you want to be in the future because you are working on something that has not happened yet, right? You're working on a new part of the project and you want to be at the tip of the timeline before you start your project. If you are behind master, that means there are changes that were made that are not incorporated into your project, which isn't necessarily awful. Maybe you're working on a file that someone else is working on that you're not even touching, right? If you're working on something completely different that nobody else cares about, then it's okay if you're behind because nobody else is ever going to touch your stuff. If you are working in the past on a new file, not likely you're going to have any conflicts. But if you are working on common or popular files in this project and you are behind in time, you are likely going to end up in a merge conflict, and the person who is in charge of the project is probably going to be very upset. And they'll yell at me.
I have a question.
They'll yell at you. What?
I have a question that's slightly fuzzy for me, trying to figure out some of this. It's two parts. One is, what is the difference between a fork and a branch if you're going to be working on it? Like, from what I understand, a branch is not affecting the main one until you merge it back in. And then the other one was, if you forked and you want to re-get any changes that have been made to the master, how do you pull those back down, or is that the same pull that you would do for your own?
So that's a great question. A branch is a divergence from time in a project. Okay, I am not the author or owner of this project. I do not have permission to make any commits to do anything in this project. If I tried to do a git push into Monkey MWA2, I would be denied. Okay, I do not have the right to make changes in this repo. The authors can. Greg Nagel can make branches all he wants and do stuff because he is the author, he is the maintainer, he's the owner, right? I cannot make my branch in his project. What I can do is fork his project to my project. This is now my project, which I have forked. And in my fork, I made a new branch. That is my branch. He does not have permission to write to my branch. I cannot write to his branch. Branches are unique to the project, okay? And each project, when you fork it, you have a separate project. They know about each other, meaning my project is technically an ancestor, sorry, his project is an ancestor of my project. His is my upstream master that I forked from, but again, it's still my project. And McSpadden MWA2 is mine, and I have permission to write there. So generally speaking, you cannot make branches in someone else's work. You make branches in your work. Now, if you are working at a software company, you have a team of people who all work on the same project, you can make all the branches you want because you probably have the ability to make commits. You have write access if you are working on it. Public GitHub, you don't, right? I cannot push to any of his stuff. So I have to fork it first, make my changes. Then when I submit a pull request, I say, here's my branch that has my changes. Please put it into your master. And I'll show you exactly what that looks like. We can do that right now. So I'm one commit ahead of Monkey Master on my branch, okay? And here, to answer your question, here's that button, new pull request. Real simple. This is the base fork. What am I trying to compare against? Monkey MW2 is a project that I forked this from. I want to look at his master branch. My head, meaning where I am right now that I'm making a pull request for, is my fork, and McSpadden MWA2. I could also, if I wanted, make a pull request for literally anyone else's copy of MWA2. I don't know why I'd want to, but I could. And I'm comparing my branch to his master. So literally what I'm saying is, look at monkey master branch, compare that to my master, compare that to my project, my fork, my branch. He's going to yell at me. Okay? You can ignore this for now. All right, so anyway, GitHub, again, has some nice features. You can talk about issues that people have filed against your product to refer to. This is why I'm making a pull request, things like that. Maybe I'm trying to fix a problem that I see in there, things like that. You have this fancy formatting. It's Markdown, GitHub flavored Markdown, et cetera, et cetera, et cetera. I should take this out so he doesn't actually yell at me. Cool. So then if I hit the create pull request button, it will generate a pull request. He will see it. He'll get notified. He'll be really upset at me. Maybe I shouldn't do it. All right, let's take a vote. Who thinks I should annoy Greg Nagel? All right. You're all with me on this. If I'm not back in 3 days, avenge my death. YOLO. Okay, there we go. That is a pull request. I've made a PR saying I want to merge my one commit from my branch into your master. And here, again, you can see what it looks like. If you click on the commit hash, you can actually see the comparison live of the actual code, right? I'm going to get in so much trouble. Cool. Looks good. That's a PR right there. That's the process, okay? You fork someone's project, you make your changes in a separate branch, you send a pull request saying, please incorporate my changes. And then discussion ensues. The author can choose to reject or accept your pull request. The author can come and judge you for it, come and yell at you personally. If they know where you live, they'll drive over and egg your house, all kinds of things. They've all happened before. They'll happen again. That's how the internet works, right? If you look at the list of pull requests here, you'll see mine, right? So then there it is. Now I'm going to go ahead and be a good citizen and close my pull request. Maybe if I'm really, really lucky, he won't notice. He's going to notice. Okay, so there it goes. I made a pull request, submitted it, and I closed it because I'm being a good person. I'm a terrible person. And I'm going to go ahead and, if I want to, GitHub has this nice option, delete my branch, meaning I made a branch just for this one change. That's the only purpose of this branch. So I don't need this anymore. We can actually go ahead and get rid of it now. And my branch is now gone. If I look back at my version of the project, nope, this one over here. Nope, that's still not mine. There we go. Okay, my branch is gone. So there you go. That's the process. That's the general GitHub process. That's how almost everybody in the MacAdmin community tends to contribute stuff back to open source, right? So I encourage literally everybody here. GitHub is open, right? When we talk about open source, we mean that really literally. It's open for people to look at, to understand, to read, to view, to learn, to gain, to play with. You can fork any project, and you can do whatever you want to it. You don't ever actually have to incorporate master ever again, right? I can take MW and say, I really need to have a feature that I know the original author doesn't want. I'm going to maintain my own fork from then on. A lot of really popular projects are forks of other projects that have diverged so heavily that they're only very barely related, right? You'll see a lot of that in the top 50 GitHub open source projects. I really encourage everybody to feel free to do this kind of thing, right? There's no penalty. There's no, aside from being judged and yelled at by Greg Nagel, There's no penalty for playing the open source world. It's a free game for everybody to do. And I hope that with this session you've gotten some familiarity with the process and kind of understand the general path here. But again, please, everybody, contribute back. What I mean is not just contribute back, share your stuff. We talked about why we use source control. It's not just for sharing complicated projects. It's also for keeping copies of your history of things you need in a place where you can always get to them, right? If you have a script that you run for your company that solves a problem you have, keeping that script in a Dropbox somewhere or keeping that just on your hard drive isn't a very good way to do it, right? Somebody else will want to look at that script. Somebody else might benefit from that. Maybe you can share that knowledge back to the world. Maybe you don't even want to share it publicly. You just want to have it in your company's private source control, because that way, maybe one day the environment changes, you got to change your script, but you still want to make sure you remember what happened before. Source control gives that ability. You can look at the evolution of projects over time. You can change things, add things, remove things. You have all that history with you. Use source control for everything. Use it for anything that's text, anything that you need to keep track of. It's the best way to keep a running live backup, a running live history, and an understanding of your own evolution. Question? Yes. I don't know where the brick. You could pass that down for him. Thank you.
Okay, now Greg gets your
Pull request.
your pull request, and he decides, yes, I like it, and he implements it. At what? All right, so he implements it. Now, how do I know that that monkey has been updated, so that now I'm so now I have the latest version?
Sorry, Greg just commented back on it, and this is amazing. That was a good PSU. All right. Yeah. Oh, that's good. All right. So, to answer your question, I need to find a good visual example of this. Oh, okay.
I did submit my pull request.
Cool. All right. So to answer your question, when a pull request is accepted, okay, here is the one that we were helpfully submitted. Cool. I'm going to go ahead and merge this pull request just like he would if he didn't hate me right now. Confirm my merge. It's done. It's now merged into master. If I go back and look at the code, okay, here it is on master. The last thing that happened is that it was merged. If we look at, dang it, not projects. If we look at the commit history, okay, here we go. That was the changes that were made. Very simple, right? So you suddenly see that now showing up in your commit log, in the commit graph. So he would either accept or reject. If he accepts it, it gets merged into master. Now everybody who now does a pull, a git pull, will incorporate those changes into their latest copy, which is why you always want to pull before you make any changes, right? So that you're always working on the latest timeline. Does that make sense? Does that answer your question?
It makes sense, but I just wondering how the communication, where you just have to get the latest version and then make the make the change, as opposed to there being some way that it's sent out. So Greg Nagel sends out something that says, okay, we're now at version 3 point whatever. And
so GitHub does have, I think this is a good example. Actually, Monkey's a better example. GitHub does have this feature called releases, where you can sort of tag a given state of your repo as this is a release version, and say, all right, I've made this change. This is the state I'm in. Here's a release. Please look at, judge accordingly, et cetera. Or maybe he'll say, I've made a new development branch. I'm testing out a new feature. Look at this one branch. Tell me what you think. But GitHub itself does not offer a mechanism for that. That's email, communication, mail lists, things like that. So there's still some other project maintenance that has to happen as a result. But generally speaking, GitHub makes most of that process very simple. So 40 seconds left. Thank you all for coming. I appreciate you being here. Hopefully you learned something out of it. If you have questions or concerns, confusion about Git, please feel free to contact me on Slack, in person. If you see Greg beating me in the hallway, I'd appreciate if someone stepped in. Thank you, and enjoy the rest of your PSU.